In this course, we can see how data power configuration is done in Windows using Docker. What we are learning here: installing and configuring the Docker, configure data power in Docker, and running the data power in Windows. Docker introduction. It's an open platform for developing, running an application. It provides the ability to package and run an application in an environment that is called container. Containers are directly connecting with the host machine's kernel. It runs on host operating system, unlike virtual machines like VMware's. So that has its own host operating system. Here is the Docker architecture. It follows the client-server architecture. As you can see, there is a Docker host, client, and a Docker registry. Docker host can be Windows system or it can be a Linux system. Docker daemon manages the containers, images, network, and the volumes. The required images are pulled from the Docker registry. Client might be Docker API or it can be a Docker CLI. You can see some regularly used commands here, like Docker images. It lists the images present in the Docker host. Docker build. You can build your own image using a Docker file. The Docker full. You can import the images from the Docker hub or from the private registry. Docker push. You can export the images what we have in your Docker host to the Docker registry. Docker run. It will create the container and start the container. See, this is the Docker architecture explained here. What are its functionalities, Docker functionalities, and what are the components in this. So Docker daemon listens to the Docker API requests and manages Docker objects such as images, containers, and networks and volumes. And Docker clients talk to the Docker daemon. It's a actually server engine. So it talks via REST API calls. The Docker client and daemon run on the same system or it can be on the different system. Docker client. So Docker client, as you can see here, in the Windows PowerShell, we can open the Docker commands and using the proper options in the command, you can execute the required commands like Docker pull, Docker build, like that we have seen earlier. When you use this Docker run command, the client sends these commands to the Docker daemon. The Docker command uses the Docker API to communicate to the Docker daemon. Docker client can communicate with more than one daemon. Docker registries. As you can see in the Docker registry, it can be a private repository or it can be a public. Public is a Docker hub. Anybody can access this Docker hub. Before accessing the Docker hub, you have to create a account in the Docker hub. Then you can import the required, whatever you require or whatever present in the Docker hub to your Docker host. So while doing the import to the Docker host, you have to use the pull command, Docker pull command. And whenever you want to push it to the Docker or your private registry, or it can be a public registry, you can use a Docker push command to push it to the Docker hub. So it can be available for other users. They can use your images you created. The Docker client can be in a same host or it can be other host. A Docker registry stores Docker images. Docker registry can be a public or it can be a private. Docker hub is a public registry that anyone can use. By default, Docker is configured to look for images on Docker Hub. When you use the Docker pull or a Docker run commands, the required images are pulled from your configured registry. What happens if you run directly Docker run without pulling the image, required image? So you want to run that image in your Docker host. That time it automatically pulls the image and then apply the Docker run command. Then the container will be in a running mode. When you use the Docker push command, your image is pushed to your configured registry. So you can use this command to load your created image or your modified image to the Docker registry again. So it can be available for other person in your organization or any general public if you are using Docker Hub to use that image. Docker images. So there can be many images. So some of the popular images you can see in the screen, like MongoDB, Jenkins, Ubuntu, MySQL, Node.js, Apache, JDK, RabbitMQ. So it is a template with instruction for creating a Docker container. You can create your own images or use created by others. To build your own image, you have to create a Docker file with steps needed to create the image and run the image. When you change the Docker file and rebuild the image, only those layers which have changed are rebuilt. Any instructions written, it creates each layer in the Docker image. Docker container. Container is a runtime instance of an image. The software that hosts the containers is called Docker engine. So Docker allocates a read-write file system to the container. So whatever the read-write happens, it's particular to that container. It's not overlap with the other containers. You can create, stop, start, move, or delete a container using a Docker API or a CLI commands. Like if you want to delete a container, there is the container ID available. If you search by Docker space PS, it will give the containers listed in the Docker host. So in that case, you have to get that ID, container ID, and delete it, like Docker space RM and space the container ID. It will delete that ID in the container. Container is relatively well isolated from other containers and its host machines. Now we'll go through some details about the data power before going to how we can enable the data power configuration in Windows using Docker. It provides security, integration, and optimized access to a mobile and web applications. It's a hardware appliance and it resides in a DMZ layer. So in hardware appliance, we'll use mostly in the production environment. For the development environment, we can simulate the same hardware appliance features in Windows. So now we are going to do the same using Docker. The following command runs in a data power container. So when you run the Docker run command, it will create a container and start running. So in this case, it will run the data power container. The container name is data power in Windows, WIN. Docker run -IT. IT means interactive, means INT together, interactive and TTY. -P, then the port you can use 9090. Okay. Then when you run this command, the following happens. If you do not have the data power image locally, okay, when you run it directly, Docker pulls it from the configured registry. So data power image pulled from the registry before applying the Docker run command. And in this case, Docker creates a new container. Docker allocates a read-write file system to the container as its file and layer. This allows a running container to create or modify files and directories in its own local file system. So if they are using Docker container using same image, two Docker containers using same image, so still it will write its own in its own file system, local file system. It will not interact with the other containers file system. Enable interactive mode. How to enable? As I said earlier, there is a flag called IT. So interactive mode allows you to access the data power CLI from the Docker console. To enter the interactive mode, you must meet the following conditions. You must start the container interactive mode by using the Docker, using the -i flag, there's interactive, and -t, the TTY flags. Or you can make it combined like -it. So it becomes interactive. You must start the derouter process with the data power underscore interactive equal to true environment variable as shown below. So data power underscore interactive is the environment variable. You have to make it that value as true, like you see below. Docker run -it interactive and some other commands or parameters, then -e data power underscore interactive equal to true, -p 9099 so this is, you can choose your port, and hyphen name, then you can give any name to the data power container if it's not existing, then space ibm com / data power. This is the data power image in the Docker host. So it will run the image and create a container. So now we can see the implementation.